Good morning, everybody. Today's going to be a fabulous day. Why, Nick, is today going to be a fabulous day? What did Mr. Lappin just do? He got me a bag of famous Amos. Just because. Okay. Those are awesome. I'll tell you, sometimes you do nice things to people just because it just makes their day. You know what I'm saying? So I'm going to do something nice for y'all. I'm going to do problems 3 and 5 with you. I mean, how nice is that? You know what I'm saying? All right, so what I want you to do is I want you guys, we're going to grab 3 inequalities, all right? We're going to grab this guy. He'll be in blue. This guy. He'll be in red. Don't worry, your faces are not being recorded right now. It's okay. They'll just voices. All right? Just voices. So if Caitlin says something, then that will be forever on YouTube. That's true. That's true. All right. So there we go. We have blue, we have red, and we have green. One of them is the easiest to graph. So anybody want to volunteer which one they think is the easiest to graph right now? Go ahead. That's right. This one, Zyla, is so easy to graph. Why? Because we have a what? We have a slope. Yeah, so we have a slope of 2. And we have a y-intercept of -5. We got to go up 2 and over 1. Good morning! So good to see you. How are you this morning, sir? All right? All right. We're doing problems 3 and 5, so I want to get caught up. Come on in, have a seat. Let's get started. All right. Now, what are we first going to plot, Nick? What are we going to plot? That's right. We're going to go down here and plot. 1, 2, 3, 4, 5. Put a point right there. Now, how do we apply a slope of 2? Up 2 over 1. Good job. Up 2 over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. And what kind of line do we get to graph in all of these situations? They're all equal to's, right? So they all get to be nice, solid lines. All right, so we're going to make them all nice and solid. There we go. All right, so there's the first line. Graph just like that. So get that on your paper. Now, we're not going to worry about shading everybody until the very end. Okay, so instead of before we were shading every single section, we're just going to remember right now if it says greater than or equal to, right now we need to be aware that if we were to shade, that's where the shading would be. But we're not going to do that until the end. Okay? All right, now we have to make a decision on which one we want to do next. Let's just go ahead and do the blue one and get it out of the way. What's the only thing I have to worry about to solve for the blue? When I say solve for y, I'm changing it to slope intercept form. So solve for y. What's the only thing we got to do? Oh, yeah, just subtract x and get it done already. All right, you're right. Subtract x. We have y is greater than or equal to negative x plus a 2. The slope of this is negative 1 over 1. The y-intercept is 2. The slope tells me I have to go down 1 unit and over 1 unit. So right here at 2, I'm going to go down 1 and over 1, down 1 over 1, down 1 over 1. And once again, you have to create a nice straight line connecting all those points. Very important that you are accurate. And last but not least, this one, all you have to do is divide everything by 4. That's right. So y is less than, now, this is where sometimes it gets tricky. X over 4, what is that the same as? That's right, 1 over 4. 1 over 4, x. And 8 divided by 4 is 2. What's our slope? 1/4, which means I have to go up 1 unit and over 4 units to the right. My b value is a positive 2. So we're going to go up positive 2, put a point right here. All right, and we're going to go up 1 and over, up 1 over 4, which puts our point right there. All right, we can also go down 1 over 4 and put our point right there. And make our final line. These are all equal to lines. So you make them nice and solid. Okay? Now, what I want you to notice right here is we have some nice points that are vertices of where we're going to shade. Okay? The red line, we are shading everything underneath because it's less than or equal to. So the red line, everything underneath would be shaded. The blue line, everything greater than that will be shaded. And the green line, everything on this side would be shaded. So where they overlap is this one area right in here. This is where all the lines overlap. And that's called a bounded region. Okay? It's bounded. You guys see the vocabulary word on your paper where it says unbounded? Unbounded means it doesn't have boundaries. It kind of goes on forever. It's like you go out to the ocean and you start looking at it, you don't see any boundaries. It just goes on, seems to go on forever. Okay? So this is the area. This is our feasible region right here that we're going to be using. Now, the first thing that it asks you to do is we graph all the inequalities. Okay? The next thing it tells you to do is name the coordinates of the vertices of the feasible region, which is the feasible region. So we're going to label some vertices here, okay? Some of them are very easy. One of them is slightly more difficult. We're going to use the graphing calculator to show you how to find it, okay? And we're also going to do it by hand. So this ordered pair, everybody, right here, where it crosses is at 0, 2. That's one of your vertices, okay? So right now, on your paper, one thing you need to have is not just the graph. You need to have the list of vertices. This over here is 1, 2, 3, 4, 1, 2, 3. So we're at a 4, 3. Those are the two easy ones because they cross nice and neat. The one that's tricky is we have the green line, right? The green line where it intersects the blue. We need to find what's called the point of intersection, all right? We need to find this ordered pair. So what I'd like you guys to do right now is turn your graphing calculators on. All right? What we're going to do is we're going to type in this equation right here. This equation is the blue line. Okay, so remember that equation. All right? We're going to type in the green line right here. There's the green line. We're going to type those in, and we're going to show you how to find things in the graphing calculator. Then we're going to do it by hand. So go to the graphing calculator. Let me turn mine on. All right, we're going to type in the equations right here. The blue equation was what? Negative, is it negative x plus 2? That's correct? Okay. Now, I'm going to go over here just for our purposes. If you ever want to change your color, if you have this type of calculator, you're going to change it to green, since I said it was green. All right? And that equation was 2x minus 5. Okay? And then you type both those equations in and you hit graph. There's our two lines right there. If you look at these two lines, there they are. Okay? So there's our lines right there. All right, so let's see where they intersect. Now, if you wanted to look at your graph a little bit nicer, what you could do is you could hit zoom, number 4, and now it looks even better. If you want to see the grid lines, you could hit second zoom, which formats your screen, and you could turn the grid lines on, and it would look even better. There we go. There's our lines right there. And what we're looking for, everybody, is we're looking for where those two lines intersect. We're going to try to find this x coordinate and this y coordinate. All right? And we're going to just use the tools of the graphing calculator to help us. Then we'll do it by hand. So, what you do, now that you have your two lines, it has to be on your screen. Okay? 2 lines on screen. Then you hit second, trace, and you go down to number 5 where it says intersect, and you press number 5. And you see how the cursor's on the blue line? You say, yeah, that's one line I want to find, the intersection of with. You press enter and it says, where's the other line? Ooh, the green line. I want to do it with the green line. I want to find where they intersect. Come on. Not working. There we go. The point of intersection. You keep pressing enter until it does it. And you guys see right now, the point of intersection, right here where this cursor is on your screen, is 2 1/3 and a negative 1/3. By the way, anytime you see 0.3 repeating, that's a third. There's negative 0.3. So what I'd like you guys to write on your paper is an improper fraction. 7/3, comma, negative 1/3. So So on your paper, right now, for your third vertice, you're going to write 7/3 and -1/3. That's what you're going to do. So please write those down. All right, quickly right now, if you wanted to find the point of intersection just by hand, one strategy is you guys could set the equation equal to each other, since you've already changed them to y equals form. And if we're going to do this to solve for x, all we have to do is add x to both sides. And now you have 3x. And then you could add 5 to both sides. And you get 7. Alright, so that becomes a 3x. That zeroes out. These right here are additive inverses right there. These are the additive inverses. And you get 3x equals 7. Divide both sides by 3. And look what you get. X equals 7/3, which we have right here. Okay? Then, what you could do is you could take this answer, and if one of your equations, everybody, is y equals 2x minus 5, you could take that 7/3 and just simply plug it in for the x. So once you solve for one, now we're going to solve for the other. Y equals 2 times 7/3 minus a 5. You get y equals 14/3 minus, now I'm going to change this into thirds, everybody. Alright, a 5 changed into thirds is going to be a minus 15 over a 3. That's what, because negative 15 divided by 3 is a negative 5. So I'm changing them into thirds. Why am I doing this? So that I can combine the numerators and the denominators the same, and you get a negative 1/3. Okay? And once again, there's our negative 1/3. So now we have all of our vertices. Okay? Now what we have to do is we have to find the maximum and the minimum based off of this function. So underneath the vertices, everybody, I want you guys to write this equation right here. Okay? We're going to write f of x and y equals, I believe it's 4x plus 3y. We're going to say 4x plus 3y. So we're going to take these vertices, which have an x-coordinate and a y-coordinate. These are all my x's, these are all my y's. We're going to plug them in to this formula. So I'm opening up a parentheses, everybody. Let's see what it equals. We have to do it for all three. Okay? I'm going to pause the video, and when I start it again, you'll see all the numbers plugged in. All right, if we do the first one right here, we have 0. 4 times 0 is 0, plus 3 times 2 is a 6. Right here, we have 4 times 4, which is a 16, plus 3 times 3, which is 9, which gets us to a 25. Here we have 28 thirds. I'll write this way. 28 thirds minus, basically, we'll say 3 thirds. Now, that's technically a 1, but I'm just leaving it as a third so I can combine these. What's 28 minus 3? 25 thirds. Now, it asks you to find what's known as the minimum number of our function and what's the maximum number. Our minimum number in this case is a 6. If you did 3 into 25, you would get 8 and a third, which 8 and a third is not the smallest number. 6 is the smallest number. And what was our biggest number? 25. And that right there is your final answer. So, in review, what am I expecting? I'm expecting you to take these 3 graphs and graph them accurately. Okay? Then the next thing we found was the vertices. Alright? And one of them was tricky. The blue and the green, what did we have to do? We had to set them equal to each other and find that ordered pair, which was 7 thirds and negative 1/3. And last but not least, we take this function right here, this function, and we plug in all of the vertices that we found, and we find the maximum and the minimum of that function. All right, and that's it.